So in this video, I'm going to show you how to name and write the formulas for ionic compounds. And so what's happening in an ionic compound? Remember, the metal is donating electrons. So in this example, magnesium is donating its 2 valence electrons. And the quirky thing about ionic compounds, the challenging part, is that you have to figure out how many metals you need for every nonmetal, or how many nonmetals you need for every metal. So if you look at this example, for magnesium to give up its 2 valence electrons, there needs to be 2 chlorines to accept 1 electron each, because chlorine already has 7 valence electrons, so each only needs 1. So the issue becomes, well, do I have to draw this out in order to see this every single time? And the answer is no. So let's look at an example. If I've got magnesium and sulfur, okay, to write the formula, instead of having to draw it out like I did for magnesium chloride above, all I have to do is the following. I say, all right, magnesium has a 2+ charge, sulfur has a 2- charge. And what I'm going to do is I'm going to cross my charges. So the 2+, that 2 becomes the subscript for sulfur, and the 2- from sulfur, that 2 becomes a subscript for magnesium. And so what you end up getting is Mg2S2. Now the reason why I cross my charges is because magnesium is going to give up 2 electrons. Sulfur will accept 2 electrons, but the only issue here is I need to reduce this. So since I have Mg2S2, I can reduce that to Mgs. And this makes sense because magnesium gives up 2 electrons. Sulfur, with its 6 valence electrons, will accept those 2 electrons. The whole purpose of this, the one above and this one, is for the ionic compound to have no net charge. So magnesium with its 2+ charge cancels out with the sulfur with its 2- charge. The one above, that would be MgCl2. Magnesium's 2+ charge cancels out with the 2-1 charges from chlorine. So you just cross your charges. Now, when I'm naming, that was writing the formula. When I'm naming, if I know the charge of the metal, meaning it is a group 1 with a +1 charge, group 2 with a +2 charge, or group 3 with a +3 charge, or your 2 exceptions, which are zinc with 2+, or silver with 1+, all I have to do is the following. I just have to write the name of the metal and then the nonmetal. Now for the nonmetal, you get rid of the ending and you add IDE to the name. So for example, Li2O. Okay? I know the charge of lithium, so I don't have to add anything other than just the name of the metal, lithium, and the anion, the nonmetal, oxygen. Instead of oxygen, it becomes oxide. Okay? And that's all you have to do. Now, well, what if I don't know the charge? What if it has variable charge because it is a transition metal? Well, in that case, you have to write the name of the metal and then follow that with the charge as a Roman numeral. And then you just write the nonmetal with an IDE ending. So if you look here, FeO, that's iron, okay? But notice oxygen has a 2- charge. So Fe must have a 2+ charge. So this is going to be iron 2, the 2 representing the 2+ charge of iron, and then you just write the nonmetal with the IDE ending, so it would be oxide. Okay? The next type of ionic compound you could have would include these polyatomic ions. Now these polyatomic ions, if you look for example at nitrate, NO3, okay, you need to learn the formula and then also the charge. But notice there's a pattern. So if you have NO3-, that's nitrate. If you get rid of 1 electron, that's nitrite, NO2-. The easiest one would start with ClO4-, that's perchlorate. Lose 1 electron, ClO3, that's chlorate. ClO2- would be chlorite. ClO- is hypochlorite. And so you need to memorize these, practice with these a lot, and then you need to memorize these and their charges. Okay? But the easy thing when you're writing the formula, nothing changes. These are going to be the anions for all of these except for ammonium, which has a positive charge, and you simply write them at the end of the ionic compound. Okay? No need to change the ending like you did before with the IDE ending. So for example, if you have MgOH, well, Mg, we know the charge of it, so I can just write magnesium. If I didn't know the charge of magnesium because it's a transition metal, I would have to include it as a Roman numeral. Okay? And then I'm just going to write the name of the polyatomic ion, which in this case is OH, and that is hydroxide. And that's it.